Alright, and for the last video, yay! Alright, so we're still doing trig. I'm still on Unit 2, Topic 2. And it looks like for this one, they want to know how high the vertical support is. So the vertical support is here, so I'm going to put an X there, 90 degree right here. Alright, so remember for right triangles, you can always use Pythagorean theorem or SOHCAHTOA. I know this is a SOHCAHTOA problem because they gave me an angle. Alright, so my very important angle is 20. Across the 90 is my hypotenuse. Across my important angle 20 is my opposite. So between SOHCAHTOA, I need to pick my winner. And my winner needs to have an O and an H, which is this one. This one has a A, and this one doesn't even have an H. So my winner is SO. So I'm going to use the trig function sine. So I'm going to use sine of an angle. The angle is 20 equals O over 8. So O is X and H is 16. Alright, I really want X by itself. So to get rid of a divide by 16, I'm going to multiply both sides by 16. 16 times sine of 20 in my calculator. I got 5.47. So my answer, 5.7 equals X. So the vertical support needs to be 5.47 feet. Alright, number 58, ladder. Josh has a 17-foot ladder. Alright, he would like to place the ladder against the side of a vertical wall. So here's the vertical wall. So that the top of the ladder is 15 feet up the wall. Alright. Safety guidelines state that the angle the ladder makes with the horizontal, here's the horizontal, the ground, can be nothing more than 70. Nothing more than 70. So that means things like 68 are great, and a degree like 71 is not so good. So can Josh safely place the ladder against the wall? So they want to know what this angle is. We don't know if it's 70. We want it to be 70 or less. So I'm going to put an X there. I know this is a right triangle. So again, with a right triangle, when an angle is involved, I'm going to use SOHCAHTOA. So here's the hypotenuse. Across the X, here's my opposite. Alright, so between SOHCAHTOA, I know that sine is my winner because I have an O and H again. So sine of angle X equals O over H. 15 over 7. Remember, trig functions take in angles. So when you don't know an angle, this is a backwards problem. So in my calculator, I'm going to push second and then sine. I'm going to put in the ratio of 15 over 17. And push enter, and I get 61.92. So I know that X equals 61.92. Whenever you push second, that means you're trying to find the angle, so it's degrees. So the question, can you safely place it? Is this less than 70? It sure is, so yes. Okay? It's safe. Alright, part B. Suppose that Josh wanted the top of the ladder to be 24 feet up the wall. So, 24 feet. You have a ladder. In order to meet the safety guidelines, what is the minimum length of the ladder? So now they want to know the length of the ladder if it's 70 degrees. Because it can't be anything more than 70. So same idea. There's my angle. Here's my 90. So I'm going to label across the 90, that's my hypotenuse. Across the angle, that's my opposite. So O and H, again, sine is my winner. So sine of angle 70 equals opposite over hypotenuse. No, the variable is on the bottom. Okay, so this isn't an easy one. This is a more difficult one. But you can just put a divide by 1 here and cross. So I would multiply 1 with 24, which is 24, and then divide by the leftover sine of 70. So let's do that. 24 divided by sine of 70, and I get X to be 25.54. So that's what you want the ladder to be. Alright, plain question. So a plane takes off. So it's going, 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 and then takes off in this direction. So I'm going to draw my plane. Fun. Okay, and it's going off into the sky like that. Okay, so this is the ground. It's going off. There's my 90 degrees. At an elevation, so when it takes off, it moves at 15 degrees from the ground. So I'm going to put my 15 right there. After the plane has traveled 1 mile, so the plane's over here and it has gone 5280 feet, how far has the plane traveled horizontally? So I want to put my variable this way, not here. Because horizontally is like the horizon, right? So right there. And yeah, you use SOHCAHTOA. Again, a right triangle, I know an angle, so I'm going to use SOHCAHTOA. Across the 90 is my hypotenuse. Across the angle is my opposite. Nothing's there, so I'm not going to write anything. So this has to be my adjacent. So in this case, cosine notes, ka, A and H. So cosine of angle 15 equals A, which is my x, over the h. 5280, x is on top. Beautiful. To get rid of a divide by 5280, I'm going to multiply by 5280. Alright, so 5280 times the cosine of 15. The cosine of 15 equals, wow, big number. 5100.08. Okay, I just truncated, I didn't round. That's fine. Even though it says round your answer to the nearest foot, I would accept it. Alright, so moving on. Part B. After the plane has traveled 1 mile, so again, it looks like the plane this way has gone 5280 feet at an angle of 15. How far has the plane traveled vertically? So they want to know how high it is in the sky. So I'm going to put my x there. Across the 90, there's my hypotenuse. Across the angle, this is my opposite. So in this case, sine wins. So sine of the angle, T, equals opposite over hypotenuse, 5280. Multiply both sides by 5280. Alright, so we got 5,280 times the sine of 15. Enter. I got x to be 1,366.56. Alright, so there is the plane question. I think the hard part about this problem is knowing how to draw the picture. So if you can draw the picture, you'll be fine. Alright, number 6. Number 6. A farmer wishes to make separate sections. Okay. All triangles are right triangles. So it looks like here's the right angle, and this triangle, here's the right angle. And then in this triangle, it looks like here's the right angle. Okay? What is the value of x? So for x, you have a squared plus b squared equals c squared. The right angle, only sides matter. So I'm going to use Pythagorean theorem. So 20 squared plus 15 squared equals x squared. 20 squared plus 15 squared. I'm just putting that straight into my calculator and getting 625. So 625 equals x squared. To get rid of a square, use square root, both sides. So the square root of 625, I get 25. That's nice. Good number. No decimal so far. So I'm going to put 25 there. Maybe it will help me later. No more x. Alright. What is the value of y? So, okay. So same sort of problem. This is a right triangle. A squared plus b squared equals c squared. In this case, my loner, the c, is 65. So it's going to look a little bit different. So y squared, a squared plus b squared equals c squared. Look, my loner across the 90 is 65. So you have to put this in separately. 25 squared is 625. And 65 squared is 4225. Alright, you really, really, really want y squared by itself. So I'm going to get rid of this annoying brother, 625, and get y squared to be 3600 square root of 3600 is, so y is going to be 60. Again, still no decimals. That's awesome. All right. So I know that x is 25, y is 60. This is a right triangle. And finally, the last question. All right. So this question, they want to know the area of this trapezoid. So the way I'm going to do it is I'm going to find the area of this, of the middle one, and of this one on the right, and then going to add all three. Then I'll add all three areas to get the area of this trapezoid, okay? So I'm going to call this triangle 1, triangle 2, triangle 3. So the area of triangle 1/2 base times height. So I can see that the base is 15 and the height is 20. When I put that in my calculator, 1/2 times 15 times 20, I get 150. Cool. All right. Area of triangle 2. 1/2 base is 60 and the height is 25. All right. So 0.5 times 60 times 25, I get 750. Wow, that's a much bigger triangle. All right, so the area of that is 750. Now, unfortunately, I don't know the area of triangle 3.